Yeah, these two topics. First page, I'd like to explain our final exam. Based on our syllabus, the time for the final December 14th, Wednesday. The time currently 3 to 5 p.m., 2 hours period. Yeah. So let me talk about this time. Yeah. So earlier, much earlier than our usual class time. Yeah, because our usual class time pretty late. Yeah, it may not be very convenient. But if this time becomes this earlier for some students, so probably you need to rearrange your, schedule, your plan a little bit. Yeah, but here, let me explain in this way. Yeah. So I try to make it as flexible as possible for you. Yeah. We know you can always make appointment with the test center, and you can choose. If this time you feel not good for you, you can choose other time slots. Yeah. So I may like you to choose still one of the 3 days, Wednesday, Thursday, and Friday of that week, same week, okay? And after this time. Yeah. So if you feel this time not good for you, you can choose some 2-hour slots. Yeah. Although I say 2 hours, but we may not need that long. The maximum 2 hours. Yeah. And I plan to run in this way. We know our final 25 questions, right? Yeah. But I plan to do this way, yeah. Because right now you have the quiz 4. Let me see. Quiz 4 completed or not? Oh, completed, right? Oh, no, due today, right? Yeah, quiz 4, yeah. As I remember, Monday today, yeah, midnight, Monday today, yeah, quiz 4, yeah. And I just assigned homework number 3 recently. Yeah. Actually, yesterday. Yeah, I assigned this one yesterday. And this one, 15 query questions. Okay, yeah, so another round practice query questions. Yeah. And the remaining coursework, so I try to, control, not giving you too much work. Yeah. So try to, control a little bit. So for our final, I plan to do this way: 15 questions. For our formal final exam. Okay, yeah. And 10 questions for quiz 5. We have quiz 5, yeah. And in this way, total 25 questions. Yeah. So in this way, you can see we just use 25 questions. We cover both assignments. quiz 5 assignment and final assignment. Yeah. But it is reduced. The amount of work reduced in this way. Yeah. And no quiz 6. All right. No quiz 6. Okay. Yeah. No quiz 6. Yeah. But we drop 2 lowest quizzes from quiz 1 through 5. Okay, drop 2. So we have 3 left, right? 3 left. 3 left. Then the scores, total scores, I will do this kind of scaling. Yeah, scaling in this way. Multiply 4/3 in this way. So I convert it to, as if. So we have 4 quizzes, right? Yeah. Yeah. In this way, so although we reduce 1 quiz, but we have the, the data for 4 quizzes in this way. Okay. All right. Another thing, a little more detail in this 15 questions in the final. In the 15 questions, 10 of them, 10 questions, concepts. 5 questions, queries. Queries. 5, so not too many, so then we can complete at our standard final test time. If I give you too many, then you need much longer time. 5 queries. I just give you reasonable difficulty query questions. Probably 2 of them relatively hard, and 3 of them not that hard. Okay, or 3 of the 5 questions similar to those in our. So let me see. 3 of 5 similar to those in homework assignment number 3. Okay, and 2 of the 5 will be harder, but we will study in the review. So that what we are going to do in the review. Review that, just these 2 weeks before final. We have 2 weeks, right? Starting from this week. This week, next week, that's basically the review part, review for final. So we will cover, those relatively hard questions. All right, so that's the and another thing regarding the appointment in test center. Appointments with the test center For the midterm, we have 3 students. Yeah, made appointment with the test center. Yeah, so no problem. So everything worked well. Yeah. So for the final, yeah, if you need similar service, yeah, so you need to make appointment. Yeah, but this time I would like to let everyone know you need to make appointment. Yeah, because for the midterm, one student didn't make appointment. Yeah, one student didn't make appointment. Yeah, but test center people told me everyone must make appointment before you use that service. Yeah. So they, because that's their standard procedure. Yeah. So we do not want to violate their standard procedure. Okay. Yeah. And another thing to let you know, when you do it in our regular classroom, so you can access your laptop, electronic device, access our class materials. Yeah. But you cannot use, search engine, communication software things. Yeah. So that's, in the classroom case. But when you go to the test center, yeah, they do not allow you to use your personal computer, electronic device, but you can use their desktop machines. Yeah, yeah, because in that way they have proctoring software tools, so they can monitor all the activities. Okay, yeah. So that's the main difference from our classroom test. Yeah, just here I give you that information. So when you do your preparation, so I do not try to make you feel surprised. Yeah. So when you go there, you're not well prepared, so then you may not feel good. Okay. Yeah. Here, let you know ahead of time, so you will get prepared mentally. Okay. Yeah. So that's another thing I like to talk about. And what's more, another thing. Yeah. Another thing I like to talk about regarding this time slot. Yeah. Because for some students, I know some students, they need to work, right? Yeah. They have their, regular jobs. They need to work. So this time, probably a little earlier for them. Yeah. Because, for the arrangement, it may not be convenient. Yeah. So you just try your best. Yeah. Here, what I mean, because here I run this final in a flexible way. If you feel, although this time, 3 o'clock too early, but if I allow you to come a little late, even 30 minutes late, I don't mind. Yeah. So you come to the classroom, I'll give you plenty of time to, complete the whole test. Yeah. So even if you come 1 hour late, that's still okay to me. Yeah. So I still allow you sit in the room, completed. I can give you, a little more extension. Yeah. If you need more time. Yeah. So I try to make it flexible. If that way you can do it in this time slot, yeah, then you do not need to make appointment with the test center. Yeah, you can use this time slot, this day, to complete the final. Okay, just let you know, I allow some flexibility for the final. Okay, yeah. But if too late, because if after 5, yeah, that's too late. So then I may like you to make appointment with the test center. Yeah. Let's stay in this way. Let me draw the 4 o'clock line. How about that? 4 o'clock line, right? If you can come to the classroom before 4 o'clock, then don't worry. Yeah, just complete the normal final exam. Yeah. But if after 4 o'clock, yeah, so probably you need to think about test center way. Okay, yeah. So in that one, I try to reduce the number of students who need to go to the test center. Okay, yeah. All right, yeah. And but at the same time, I need to, talk to the university classroom people. Yeah, make sure they make our regular classroom available at that time. Yeah, I try to use the same room. I do not want to change, but for some special situation, probably if I change, I will post the new room. But I feel usually I can get it. Yeah. So yeah, because another option, we can use the department conference room if we need. Yeah. Yeah. All right. So that is for the final. Any question, just let me know. So you type in the chat area so I can see, I can answer your question. Otherwise, I like to move to the project part. Yeah. In my next slide, I would like to talk about 2 projects. Yeah. I will talk about project 1 first, then project 2. Project 2, we do not have much time left, but I like to do something in project 2, do something reasonable in project 2. No. I'll be back in 2 minutes. Yeah. Here you can think about what question you like to ask. All right, so let's continue. So second topic, projects. All right, yeah. I like to stick, our 2 projects plan, although the time is very limited, okay? But I try to find a reasonable way. Okay, try to find some reasonable way. Yeah. Right now, I look at the project 1 submission. Project 1 submission. Only 5 students submitted. We have total 14 students. So 5 out of 14 submitted at this time. Yeah. That means still we have 9 students still working on this project. Yeah. And I will provide help. Yeah. So probably, these students, they may have some technical difficulties they need to work out. Yeah. From my side, yeah, I will give you another example to help you, solve some technical problem. So what I'm going to do, yeah, so yeah, by Wednesday's class, I talk about that another technical feature. So I will do this. All right. Remember that editing feature, right? That editing feature. In editing feature, there is the hardest part is how to identify rows to be edited. Okay, yeah. There are two cases we need to consider. The first case with primary keys. Second, without primary keys. Okay, this one, we just use the primary keys to identify. Straightforward, okay? This one, we need to use appropriate. Column values. To identify, yeah. So there are two tables, 2 out of 5. There are two tables, we need to do that, yeah. So in my examples, I will show you how to do that, okay? In my example, I will use Ajax technology to do that, yeah. And on Wednesday, after I made that example by Wednesday, so Wednesday, I will talk about this Ajax. I will explain that. Yeah, I will explain this Ajax technology. Yeah. For some of you, probably, you're not familiar with this powerful Ajax technology. Yeah. So I will explain in class. Yeah. Yeah. So after that, I try to help you understand the code on Wednesday. Okay. So I produce another version, sample version for this feature, editing feature. After that, now, those 9 students, you will do deletion, right? Yeah. Deletion. Because deletion, you need to identify the rows, right? But you can use, editing feature the way we do it in editing feature, same way. To identify the rows. You can reuse the code. So, yeah, but you need to understand the code first, and then you can modify the code. Okay, so same way to identify the rows. Yeah. So then I hope after that help, it won't be that hard. Okay. it won't be that hard for those 9 students to complete the remaining part of the project. Yeah. So that's project 1. After that, for project 2, here I do not want to skip it, yeah, because although our time is very limited. Our time is very limited, yeah. But I noticed most of our students, you need a little more web development experience. So here we use this project number 2, to give those students, especially for those 9 students. Those 9 students, you need a little more experience. So let us use project 2 to extend our experience a little more. Okay, yeah. But I will provide you a lot of help in a similar way as in project 1. Okay, yeah. Still, we need to manipulate data, but this time different set of data. Yeah, and I give you 80% of the features. So in my code, in my sample code, you get, 80% of the features. Yeah. Yeah, I explain all the features. Okay. Yeah, you just learn. Yeah. Learn the, implementation techniques. Yeah. Then I give you 1 or 2 small features. Yeah. I leave, after that, leave 1 or 2 small features for you to implement. Okay, yeah. Hope in this way, it's doable for you, not too hard. Yeah. Yeah. So in this way, I hope you get a little more experience after another project. Okay. Yeah. 1 or 2 small features, it should not be that hard. Okay. Yeah. But you need to do something. Yeah. So I should not give you, the whole project. That's, too easy. So, yeah. You need to do some work, right? At least you need to do some, your own work. Yeah. All right. So that's the project issue. Yeah. Any question for these 2 things, final exam and the projects? Yeah. Let's move to our next topic. Yeah. So we still, I like to complete one thing is that indexing. I have a little more to explain. Yeah. Second, I need to give you the complex queries, another important topic. Yeah, I like to talk about. Yeah, yeah. We only have a little more than 30 minutes. Actually, yeah. Let me say 30 minutes. Oh, when is the due date for project 2? Yeah, basically the end of the semester. Yeah. More specifically, as the due date, I set this December 18, Sunday. December 18, Sunday. Okay, yeah. And I will make that project 2 available quickly after Wednesday. Yeah, Wednesday I need to complete the project 1 part. Yeah, editing feature, project one explanation. So I need to complete that part first. But at the same time, I find the project two topic, the data topic, and so I can write a description and I can, prepare sample code for you, okay? Yeah. So the next week I have time to go through my sample code, okay? Project two sample code. Yeah. So then you try to find the time to do the remaining work. It is some work, so that's another reason I try to reduce your theoretical coursework assignment and try to free some extra time for you so you can put on project two. Yeah. Okay. Yeah. All right. Yeah. So that's the plan. Yeah. Next topic. Yeah. 8.1 MAR indexing. Yeah. So I have 3 slides. I want to complete this topic. Yeah. Primary indexing. Yeah. That topic. Yeah. All right. Dense index and a sparse index. This concept. Yeah. After we learn the primary index, yeah, I hope you have some little impression. Yeah. So probably I will recall a primary index a little bit. Yeah. First, this concept, dense index. Yeah. So that is just from the words, you can guess the meaning. A dense index has one index entry for every search key value. Yeah, search key value. All right, think about, yeah. We have a table, okay? Yeah, table. Then there is one column, yeah, think about. We can use it as a key column. So we have search key. And each search key, you need to have one index entry for it. Yeah. So one-to-one correspondence. Yeah. In that way, you have this dense index. Yeah. Okay. Yeah. And hence one record. So one search key corresponds to one record. So here, yeah. Because we assume unique values. Yeah. Unique values. So one entry corresponds to one record in the original table, right? Yeah. So this kind of index, so we call it dense index. Yeah. If you use this definition, you want to compare it with the primary index. You can see the primary index is not a dense index, not dense. Yeah. Why it is not dense? Yeah, the reason is very simple. Yeah, we recall the structure of primary index. Each primary index entry corresponds to not one record in the original table, not one record. Remember that the anchor record, that concept, anchor. Yeah, one index entry for one block anchor. Yeah, so we know on the here the diagram. So let me just use the this way. Let's imagine we have a sequence of blocks in hard disk. Okay, block 1, block 2, block 3. Okay, block 2, block 3, and so on. Okay. Each block, we know it can contain multiple records, multiple entries, relatively big, yeah, but not too big, okay? Yeah, one block. Yeah. One block, you can imagine, corresponds to one page. In operating system, you have that page concept, right? That page concept in operating system. Yeah, it's not a, other pages. Yeah, the special page concept. Yeah, in OS. Yeah. So every time when you need to load the data, you load one page or one block from hard drive to the main memory. Yeah. The reason is simple. If the amount of data you want to load is too small, it's not efficient because you need too many trips from main memory to hard drive. That's not efficient. If the data unit, each time you load, if it's too large, then it's still not good because the bandwidth limitation. Yeah. The bandwidth limitation. The data bus, right? Data need to send through the data bus. Data bus has certain bandwidth. Yeah. If the data size is too large, you need to split into, still multiple trips. You cannot do it in one trip. Still, you need to do it in multiple trips. So you will not save. Yeah. So based on that, so people use appropriate size, one page or one block. Okay, all right. And here, for our primary index, each block, you just put one entry to locate the block location. Yeah. So that's why this block anchor, because block anchor, that is the first entry in each block. Yeah. So your 1-to-1 is one primary index corresponds to one block anchor, not one record in the original table. That's different. Okay. Yeah. So based on this definition, the primary index is not dense. It's a sparse. So we call it sparse index. Yeah. So let's look at the sparse index concept. Yeah. A sparse index has index entries for only some of the search values, not all, part of it, some of, because we feel we do not need to cover all the search values. We only need to cover a portion of the search values. It's enough. Yeah. Because we can use the binary search. We can use the order information of the search keys, binary search, order information. So we can still, so we can find the block that contains the search record. Yeah. Here. So the goal is, so here the goal, find the block that contains the record to be searched for. Yep. That block. Okay. Yeah. Because you need to load the whole block anyway, right? Think about that. Although our search operation, we only need to find one particular record. But we know we always load one whole block from hard disk to main memory. Okay? Even you only need one record, we need to load the whole block. So from that, property, so you can understand, we do not need to make entry to record one-to-one correspondence for that primary index. Okay, we can use sparse index. In that way, we can make our index files even smaller because sparse, okay? To cover the original data, we reduce the number of index entries to the minimum, okay? Yeah, the index, make our index file as small as possible, but we can cover large number of records in the original file, okay? Yeah, using the sparse index way, okay? So that concept, all right. Comparison. If you want to do comparison, you have advantages and the disadvantages, okay? Yeah, here. A dense index is larger than from the space usage, space point of view, larger, but a dense index supports unordered file. Yeah, so that's another important property, unordered file. Okay, yeah, unordered file. Yeah. Or sometimes you can think about, your data may not be ordered. Think about that. Okay, yeah, if your data could not be ordered, yeah, if there is no total order for the domain, yeah, for the data domain, you cannot order your data. Yeah, that kind of possibility. Yeah. So even for unordered file, you can still use dense index, right? Because one-to-one correspondence. You use the one-to-one correspondence, you won't miss any record, right? Yeah, but for unordered file, you cannot do the binary search, right? Yeah. So that's the important thing. So it does not support binary search. Not support binary search. Okay, so in that way, if you do not do the binary, you cannot save space, right? No, you cannot jump. You cannot skip certain number of records. If you skip, you get lost. Yeah, think about that. If you use the sparse index, you skip certain number of records, you cannot cover them. You cannot recover. Yeah. Only when you can sort your data file, you have the order information you can use. Then by the binary search, you can recover those records that do not have the index entries mapped to them directly. Okay? Yeah. Right. Because you can make good prediction. If you can order the data, you can make good prediction. But here for unordered file, you cannot order your file, your data. Yeah, you cannot do that kind of operation. You cannot make good prediction. Okay, yeah, you have to do linear search. Yeah, so for this case, you have to do linear search. Okay, yeah. So then, you have to use that dense index. You cannot use sparse index. Okay, yeah. All right, so that is the concept, dense index, sparse index. Yeah. All right. Next, retrieve a block with a given primary key. In this slide, let me just repeat the whole procedure. How do we retrieve a block with a given primary key? Yeah. Yeah. Here, the given primary key, yeah. It's better to say, yeah, because here, and this name. Why you use the primary key, right? And what's the exact meaning of the primary key here, right? Yeah, we know there are two different meanings, right? In a table, we have a SQL primary key, but in the primary index, we have another meaning of primary key, right? Yes, yeah. All right. So here, yeah. Anyway, so I feel the word used here, not quite accurate, yeah. So probably it's better. Yeah, I would like to change with a given search key is better. All right, given search key, more accurate. Yeah, because it's not necessarily a primary key, right? Why primary key? Yeah, it's just a regular search key. Yeah, so that will be better, more accurate. Yeah. So let's look at the procedure. Yeah. Well, yeah, here, search key, you see? Yeah. Given a search key K of a record, okay, yeah, we want to find the record that contains this key K and load it from hard disk into the main memory. So that's what we need to do. Yeah. How to do it? So let's look at the details. Assume that a primary index is constructed based on this field. Yeah, that's fine. Yeah. So yeah, we have a primary index file, right? It's a secondary file. Yeah. So we know the meaning of that. A primary index file is constructed based on this field. Yeah. Then we do the binary search on the primary keys to locate the position. Yeah. Yeah. Here we talk about primary keys of the primary index file. Yeah, that's no problem, right? Yeah, because we already assume we have that primary index. Yeah, and that primary index file must have primary key, right? Yeah, and we know the data there is sorted. Yeah, the data in that, the entries. Yeah, the entries inside that primary index must be sorted. Yeah. So we can apply the binary search on all the entries in the primary index. Okay, yeah. On primary keys, the binary search. Okay, so we can find the location. Location. The question is, what do you mean find the location? Right? Yeah. Locate the position. What do you mean? Locate the position. Yeah. Its precise meaning is like this. We get this inequality. This inequality. Because you get two adjacent primary keys. Yeah. These two, they are two adjacent primary keys. In the primary index. Now, you can see the first one, K of I, second one, K of I plus 1, are adjacent. Okay. Then the search key, K, is between the values of these two primary keys. Okay. Yeah. Could be different. Yeah. Most likely could be different. Yeah. Yeah. All right. Yeah. So we can always find this interval that covers K. Okay, yeah. So that means you find its location. Okay, all right. Yeah. All right. Yeah. Require here that the original data ordered on the index field. Yeah. On the index, yeah, because in the primary index, it's original data ordered. Right. Okay, yeah, original, yeah. So here, this is a strong requirement. This is a strong requirement, yeah. But because, yeah, here, yeah, I mean, yeah, actually this requirement, yeah, we need to elaborate this, because this restriction is too strong. This restriction is too strong, but if, yeah, so original, I think its meaning is, ordered in primary index, then it's not a problem, okay? Ordered in primary index, that's no problem, but not in the original file, not in the original table. That's too much. Yeah. So we should not require the data ordered in the original table. Yeah. Just in the primary index, then no problem. Okay. Yeah, I think this is the meaning. This is the meaning. Yeah. Then it's not a problem. Okay. Yeah. And the next one, then the pointer, yeah, here, equal sign, right? Yeah, okay. Unequal, so here, unequal, yeah. And the equal here, equal, unequal, okay, yeah. That means this pointer P of I tells us the right block to be loaded. Get a pointer P of I to reach the disk block containing the record with the key K. Yeah. Not P of I plus 1. Yeah. Not P of I plus 1. Yeah, because that one, that's the next block. P of I plus 1, that's the next block, not the current block. P of I is the current block. And we are sure that P of I, this block, contains the record with search key K. Yeah. So then you should load this block. Okay. Yeah. All right. Yeah. So reach the, yeah. All right. Then after that, load the disk block into the memory, load the whole block. Okay. We know there must be a record in this block that contains the search key K. We know that. Okay, we're confident. Yeah. Why we know that? Binary search, the data ordered. So, based on that, we can make good prediction. So we know the record to be searched for must be in this block. So we load the whole block. Okay. Yeah. Yeah. Into the memory. Yeah. So you can assume from now on, that disk block is inside the main memory completely. So the next thing we need to do, we find the record in memory from that block. From that block. Okay. Yeah. Another search, right? Yeah. Find. Yeah. Right. Whole block. Yeah. Use the linear search. This time we use the linear search to find it, not the binary search. Can you imagine why? Why? Yeah, because when we loaded this block, we didn't locate the record to be searched for, right? We locate the block that contains the record to be searched for, but we didn't locate the record to be searched for, right? We only know this whole block contains the record. but we do not know where to find it, right? We need to do some work, the remaining work. So this is the remaining work. But when we do the search in the remaining work, we can only use linear search. We cannot use the binary search. Why? Because this block contains original data. This block contains the original data. Okay? Yeah. Original data. And we know original data is not ordered based on this key, right? The index data is ordered, but the original data is not ordered. Okay? So if you search the index data, you can use the binary search. But if you search the original data, you cannot use the binary search. It's not ordered. So that's the reason you can only use the linear search on the original data. Okay? Yeah. So that's the whole procedure. That's the details of the whole search operation using the primary index. How do you find the data? The record, correct record, stored on a hard disk. Okay, yeah. All right, yeah. So next, a major problem. Yeah, so let me complete this last slide for today. Major problem with the primary index. Yeah. Yeah. So it's, you know, it's disadvantage. Yeah, actually quite significant. Yeah. So let me talk about a little bit. Yeah. Some problem occurs when data is added and deleted. Yeah. So when you add a new data item or delete an old data item, those operations are quite expensive. That means you need to do a lot of work in order to, you know, maintain the structure right. Yeah? Because after you do those operations, you may break the original structure. You have to recover the original structure. That recovery operations, very expensive. Okay? Yeah. Yeah. A typical problem for ordered files. Yeah. So that's the typical problem for ordered files. Yeah. And we know that indexing technology, most, you know, dominant. Yeah, we know the primary key is the most commonly used way to construct index files. Yeah. This is the typical problem. Yeah. Yeah. After insertion and deletion, to recover the ordered structure, the cost is high. Okay? Yeah. Yeah. Next question is how to improve. Yeah. Change in a primary index. Yeah, because sometimes, you know, for some special applications, people may like to improve. Try to make the, you know, dynamic data management more efficient. So people want to make you know, these operations faster. Okay, yeah. All right. Move records to make space for the new record. Yeah. Because when you arrange index entries, it's, you know, back to back, right? You cannot leave any room between two adjacent index entries, right? Yeah. Yeah. When you do insertion, there is no room between two adjacent index entries. So you have to move, you know, Yeah, to make space. Yeah. Change anchor records in some blocks. You may need to change the anchor records, right? Yeah. And to change some index entries. You need to do all this kind of changes when you try to maintain the primary index structure. So then you can imagine how much work you need to do. Okay? Yeah. All right. Yeah. Conclusion. Yeah. At the end, the conclusion. A more advanced data structure is needed. Yeah. So here we're not happy with this data structure. Although it's simple, yeah, it has a lot of advantages, but still we're not very satisfied because we feel, yeah, in some special situations, so we don't want that kind of maintenance cost too high. So we want to reduce that maintenance cost. But we need to pay. In order to solve this problem, you need to pay. Yeah. So what do you mean you need to pay? You need to design, make more advanced data structure, much more sophisticated than primary key index. Yeah, you can solve the problem, but the solution is very complicated. All right, yeah. All right, so let me stop here today. And next time, we will do the complex query part, preparing for our, 5 query questions in the final exam. Yeah. All right, so that's